Okay, final question in section 2.1. It says a golden rectangle has a length to width ratio called the golden ratio, which is approximately 1.62. Well, what does that mean? Let's look at our rectangles here. I'll make a rectangle here, and I'll just pull down. Let's use this rectangle here. And if we make it, that looks like a square to me. I don't think I chose. There it is. There, rectangle. If it's 1.62 is the golden ratio, that means for every 1 meter. Oh, that's not right. For every 1 meter of width, the length will be 1.62 meters. Okay, so if it will be proportionately larger. So if I make a 2 meter length here, the length will actually be 3.24 meters. It will be double this. So if I double this, I will double, or if I double this, I have to double this. That's the ratio called the golden ratio. So what we can do is we can actually set that up as, I'll erase that now. Choo, choo, choo. Is it gone? Choo, choo, choo. Choo, choo, choo. Choo, choo. Well, I'll keep it here. 1.62 meters. If I set this up over here, I can actually set it up as a ratio. We'll call it a width to length ratio. L-E-N-G-T-H. And if I insert my numbers here, I get 1 to 1.62. And then it asks us, which of the following dimensions of rectangles are examples of the golden rectangle? So we have a width of 24 and a length of 38.9. Well, how are we going to figure out if this is actually a gold, if this is proportionate? Now, I can't really put this equal sign yet. I shouldn't do that. 38.9. I can't put my equal sign yet here because I don't know if it's proportionate. I have to check first. So this is easy. I know that I multiply 1 by 24. I got to figure out is 1.62 multiplied by 24. Does that give me that second term? So 1.62 times 24 equals 38.88. That's pretty darn close. So I can say, yes, that is approximately a golden ratio there because it rounded up to 10th position. Let's look at another one. So we have our golden ratio here again. I'll just do a new one. 1 to 1.62. Is that going to be equal to 52 to 120.5? Well, I know I multiply this by 52. Something doesn't feel right about this one, but we'll see. I take 1.62 and also multiplied it by 52, because if it is multiplied by 52 and the golden ratio, it should be proportionate, and it's not. It does not equal that. It actually equals something completely different, so that is not blah, blah, blah. Yes, yay. It's golden. It's golden. I'm losing my mind doing these problems. Let's check the last one. If we look at 1 to 1.62, does 348 compared to 565 work as that golden ratio? Again, this is pretty easy to figure out what I multiply it by. But does it work with the bottom one? Drum roll, the anticipation. It's so 1.62 times 348 equals? No, it doesn't work. Well, it's pretty darn close, isn't it? Oh, let's say it works. Yes, good enough for me. Pretty darn close to the golden ratio. It works. The last question says, if the width of the golden rectangle is 6.4, what is its length? Well, this is really tough. So we have to set this up as 1 to 1.62. And over here we have 6.4 because we know its length. Sorry, we know its width. We know its width right here. 6.4. What is its length? Well, really, it's not that hard, really. I know that I have to multiply it by 6.4, multiply it by 6.4. And if I go over here, take my calculator, say, what's 1.62 times 6.4? It will tell me the answer is 10.368. So it's 10.368 meters, and that is the answer for your length of your rectangle if the width is 6.4. Okay, congratulations on completing section 2.1. Tomorrow we're going to start section 2.2, so please be ready, and we'll see you in the morning.